What's up, you data friends? It's Yanis here and welcome to my channel. In this video, we are going to go through a supervised machine learning model. This is going to be a classification example, and more specifically, we are going to try and solve this spaceship Titanic predictions Kaggle competition. So if you follow this link, you're going to read about this competition over here. We are going to try and predict which passengers are transported to an alternative dimension, yes or no. So it's going to be a 0 and 1, which is basically a classification machine learning model. If we look through the table of contents now, so what we're going to cover in this video, we're going to start by explaining what is machine learning very quickly. Then we're going to go through the machine learning process. Then we are going to do some data cleaning, data visualization. Then we're going to deal with the missing values. We are going to investigate distributions. We are going to scale our data and then turn them into numeric representation. Then we are going to select the most important features. And then we are going to train and run our model. Then when we have our results, we are going to submit our results into the Kaggle competition and check our score. In the next video, we are going to try and improve our score, so our model. So we're going to try things like model optimization. We're going to try a new way of replacing values. We're going to try and run the model with less values. We're going to try the recursive feature elimination algorithm. And then we're going to run our final model, export our results in a CSV, and then we are going to build this Power BI dashboard from scratch. And just a quick note here, I am going to assume that you are not a beginner in Python for this tutorial. So if you are a beginner in Python, I suggest watching my previous videos. So this video here is about beginners in Python, where we go through Numpy, Pandas, the joins, how to visualize data, and then a beginner's example in machine learning, which is this linear regression, which is basically my previous video. And as always, all of the files, which is the raw data, the Python code, and also the PBIX file, are going to be stored in my GitHub repository. I'm going to have the link in the video description. And before we start this tutorial, let me just say that if you're passionate about data analytics and data science, then I would really appreciate it if you click the like button, subscribe to my channel, and enable notifications for my future videos. Right, starting this tutorial, what is machine learning? So machine learning is an art of programming computers so they can learn from data. So we take some raw data, so this Excel file over here, we say to the machine learning model that I want to be able to predict my Y, so this column over here, whether we are going to transport the people, yes or no. The computer is going to learn from this data, and then next time when I'm going to have new raw data and I'm not going to have my Y, which is this column over here, then the computer is going to know exactly what to predict for each row. If we go back quickly, machine learning uses statistical models and algorithms to perform tasks like prediction and classification without explicit instructions. So we basically feed the data and then the computer is going to return results, predictions. And then machine learning is a subset of artificial intelligence. Right, moving on to the machine learning process. So this is the process we typically follow when running machine learning models. We start with the problem formulation. So what are we trying to solve? What is the problem? Then we need to gather the raw data that is going to help us answer those questions, so answer the problem. Then we are going through the data pre-processing phase. So this is where data scientists spend most of their time cleaning the data, aggregating the data, joining the data, transforming the data, doing feature selection, feature engineering, etc., etc. Then we're going to need to split our raw data. So 70% we give to the model so it learns, so known data, and then 30 or 20% unknown data that we're going to use to evaluate our model later on. So data that the model has not been trained on. Then we need to select our model. So depending of our problem, if we're trying to predict numbers or classes, or if we are not predicting, or if it's a time series, then we have a lot of different models to choose from. Then we need to evaluate our model on that unseen data. We need to do parameter tuning, then rerun the model, keep running this until we find a model we are happy with. And then we run our final model with the parameters we have identified. And then we deploy the models. We can share the results of our model with, in our case, we're going to use a Power BI dashboards, but maybe that's a web app or an application or a website or anything else. Right, going back to the packages and libraries we are going to use. We're going to use Numpy, Pandas, Matplotlib, Seaborn. So we've explained all of these in previous videos. And then from sklearn, this is the library we use for our machine learning models. We're going to use everything you see over here. So you can actually copy this and paste it. Here, I'm just changing the scientific numbers to float. This one is so we can increase our plots. This one is so we can view all of the data frame. And this one is to remove the warnings. So if you're missing any of these libraries, you can type in pip install and then the name of the library, and that's going to install the library in your local PC. So if we run this quickly, next we need to load our raw data. So we have 3 files. The first file is the train, then is the test, and then is the sample submission. So let me run it very quickly. And then if we quickly view those files, so this is the train file. As you can see, we have 8,694 rows, and this one has the Y, which is a column we are trying to predict. Then if we check the other files quickly, so the other one is the test. Test is going to be exactly the same, so it's exactly the same file as the train. If I quickly put it below, but in the test, we are just missing the Y variable. So we are missing the transported column. And this is the column we are going to predict. Then we are going to submit those predictions using the sample submission. So sample submission gives us an example of how the submission should look like. So it's all the passenger IDs from the test file. So 4,278. If we check the test file, which is this one, if you check, it's 4,278, it's exactly the same, but the sample submission should only have this column, and then next to it should be our prediction, which is this sample over here. Right, going back to the files, in order to load the files in, you need to type in pd.readcsv, then in the brackets, you need to paste the location of your file and then the name of the file. So depending from where you download this data from, it's going to be in my GitHub page, but you can also download it from the Kaggle Competition. Then you copy the path from where you download that file in here, and then you save them into these DFs over here. Down here, I'm just printing the shape. So the first file has 8,694 rows and then 14 columns. The second file has 4,277 rows and then 13 columns. The difference is that Y transported column, and then the submission file, we are going to make prediction on 4,277 samples or rows. And if we quickly run the head of the raw data, so we can view our data. So this is our data, passenger ID, home planet, Chrysler, basically all the columns we have in our train, which is this one over here. Right, the first thing I always do when investigating a new data frame is checking for null values. So the first thing I do is I type the name of my data frame, .isNull, and then I sum the null values. And as you can see, we have a lot of columns that have a lot of null values. So this is something we need to keep in mind because we need to deal with those null values, which I'm going to show you later on. The second thing I do is that I always visualize the data types. So we put our data frame, which is raw data.dtypes, and this is telling me the data type of each individual column. And as you can see, home planet is object, cryosleep is object. So because these are objects, we can't really use them to visualize. We need to turn them into strings and then the numbers. So age or whatever other column is a number. So these ones, we need to turn them into integer or float so we can visualize the data. Because if it's object, then we cannot really do any visualizations on them. So exactly the next thing I do over here is that I'm changing the data type so I can visualize the data later on. Here I have all of my string columns, so these are the character columns, and if you check the Excel file, all of those columns are basically characters. So passenger ID, as you can see, is characters, home planet is character, then cryosleep is character, and then down here I have the numeric, so age. Let me close this so it's not confusing in the test. So age, then we have the room service, then the food court, then what's that, shopping mall. So I have all of my numeric columns over here. And then what I say is that for S, so string in this string list that I have just created, then I want you to take the raw data S. So S is going to start with passenger ID, and then I want you to change it to raw data S dot as type string. So this is going to turn all of the S's in this string, which is basically all of these columns, into strings. And then the same process for numeric is going to change all of these numeric columns into floats. Right, moving on, the next thing I always try to do is to investigate all the elements within each feature. So for each column, I want to see what kind of values does that new column has. So I say for column in raw data, so this column is going to loop through all of the columns in our raw data. So let's visualize it quickly. Let's do raw data.head over here. So we're going to go through all of these columns. We are going to store all the unique values of that column into the unique value. By the way, I have try and except here. I don't remember why. I think one of them was failing, so I had to do the other. I think it was because some of them were objects, some of them were strings, and some of them were values, but I think this np unique alone should work. I don't think I need try and except. Anyway, then I am counting the number of values within those unique values. So for example, home planet only has 1, 2, 3, 4 unique values. So this numeric underscore value has the length, so 4, 1, 2, 3, 4. Then I'm saying if this numeric value is less than 10, then I want to print the column name, the numeric value, so the number, and then also the unique values within those numeric values. If it's more than 10, then I only want to print the column and then the length. So this NR is the length. The reason I have this is because for passenger ID, for example, because we have 8,693 unique values, I don't want to print them. It's going to be too much. If it's more than 10, I only print the column and then the length. If it's less than 10, I print the column, the length, and also the unique values. So now we can see that for home planet, we have Earth, Europa, Mars, and NAs. For cryosleep, we have false, true, and then NAs. For cabin, we have a lot. Then for destination, we only have 4 destinations. For age, 81, VIP, 3. Then the rest is a lot, and then transported is only true or false, which is our Y variable. So now we need to start with cleaning the data. And the column I'm going to start with is the cabin. So by the way, this one is so we can print all the rows. So what I do here, actually, did I run this? It's not changing anything, but it's going to return the same results. So if I run this, so I can investigate the unique cabins, because I don't know why I have 6,461 cabins. So if we run that quickly, we can see, so we cannot really visualize them. That's why I have this one, it increases the size. If I do this quickly, you can see all of these are the unique cabins we have, and we're going to need to do some feature engineering here, because as you can see, they start with a letter. So I'm going to name this deck later on. Then we have the number, so all of them follow the same format. And then we have the side. Actually, if you read through the nodes over here, we can actually see the nodes for the cabin. So cabin, you can see we have the deck, the num, and the side. So this is basically the deck, this is the number, and this is the side. And then if I count the values, we can see that we have a lot of duplication too. It's not actually duplication, but we have 8 rows in this cabin, 7 rows in this cabin, then etc, etc. So now we're gonna try and separate this cabin column into these 3 columns over here: tech, num, and site. So down here, what I do is that I create a copy of the file. So I'm saving all of my raw data into this raw data clean, because now I'm going to start cleaning that file. I'm going to start changing the data frame. So I want to keep the original data frame as is, and then apply all the cleaning things on the new data frame. So in order to add these 3 new columns now, I need to first name them. So I say raw data clean, which I have just created. I name these 3 new columns, and then I say equals raw data clean cabin dot str dot split. This dot split is going to split the column given every time you find this slash over here. So if we check the results, by the way, then I delete the cabin and then I visualize the results. So if I run it quickly, we can see that we no longer have cabin. So before we had the cabin. Where was the cabin? The cabin was here after cryo sleep. Now we don't have cryo sleep. You can see we don't have cabin because we've dropped it. However, we have broken it down into deck, number, and then site. And as you can see, we have the deck and then the letters, the num, which is the number, and the site, which is string again, which is letters again. Right, moving on, I'm gonna try and visualize the data. So if you check my previous tutorials, we always run pair plots on our numeric columns. So what I do here is that I say sns.pairplot, then I select the numeric columns we have. So I could actually just paste this list we created over here, the numeric, but I have just copied this and then pasted it down here. The reason I've done this is because I want to have my hue, so the category I'm going to break it down, transported. So I needed to add 1 more column in that list. So that's why I copied and pasted. So if we run this quickly, just to see if there is any good relationships between these numeric columns and also our y variable, which is the transported, we can see that it's not that easy to pick up results. So we don't really have very good relationships. However, as you can see, we could break it down. So this spa and food count, we can see that people who got transported usually don't spend much on spa, but they spend a lot on food count. There's a similar situation down here with the VR tech and the food count, then similar situation with these graphs over here. So yeah, they do have some insights. So shopping, mall, and spa. So people who spend a lot on, sorry, it wasn't shopping mall, it was it was shopping mall. People who spend more on shopping mall and not as much as spa are people who tend to get transported. So what I basically pick up from this graph is that people who got transported, so equals true, they don't spend much money on spa. But we're gonna keep investigating our data before we run our model. So the next thing I do is after we investigate our numeric columns, then we want to investigate our categorical columns. So the columns that are characters and not numbers. So again, this code, we've shown it a lot in the previous videos. First, we need to specify the categories. So the columns we want to look through, and all of these ones are categorical. Even number is categorical. I might need to change that later on. Then this is to set the size of the plot. And then down here, we say for F feature in these categories, then we want to create this count plot. We want to set our X into this F. Then we want to set our data into our raw data clean. We want to set the palette to set3, which is these colors you see down here. And then we want the hue, so the column we're going to break it down by, which is this one over here, is like the legend. We want it to be transported, so yes or no. So this for container in ax.containers, this is so we can plot the numbers. This plot ticks is we set the rotation to these x tickers to be 45 degrees, and then plt.show to show the plot. So if we run this quickly, we can see that for Europa, Earth, and Mars, the one that stands out is that from Europa, we transported more people versus the people that did not go transported. From Earth, it's the other way around. And then for Mars, it's similar case, but not to that extent with Europa. Then for home planet, again, true and then false. We can see we need to put the percentages to get more meaningful results here when comparing. Cryosleep, not much interesting. Destination, not much interesting. VIP, not much interesting. Transported, we can see cabin C is quite interesting. Cabin B is quite interesting. You can see we have more ones, so trues, than the false. Then for the deck, this is the deck. Then for the num, this is where we need to further investigate this because this seems to be numbers and not categories, so we might need to change it. I'll have it later on actually. And then for the side, again, is not that interesting. So what I did later on is that I have taken this num and investigated it further because yes, it's a category, but they are actually numbers. So the first thing I need to show you, if we take it, so we check the unique values of these nums. So if we do dot unique raw data num test, oh, I need to run it. So wait, we run this, we take it from raw data clean, then we run it. So you can see we have a lot of numeric values here. So what I do down here is that first I increase the size of the plot I'm about to create. Then I save this raw data underscore clean into a new data frame. So I'm naming this num, which is the number, underscore test underscore row. So this is so I can test it. Then I am saving into this num test everything but where the num is NA. So this NA, let me show you. So this num NA here, actually let me select them so you know exactly what it is. So let me run this and then so this is excluding, so I'm gonna just include it for now. By the way, because we've run it, it's not gonna work, so I think I need to do this. So I'm gonna show you what I'm gonna exclude. There we go. So all these rows, because they have NA in num, so if we scroll to num, you can see they are NAs. So all of these ones, I exclude them with this line over here. Then I am changing my num into integer, so I can apply calculations on it now. And then I'm creating this histoplot down here. So I say sns.histoplot. I want to set my x into num. I want to take my data from this new data I've just created. Palette is the same as before. Hue, which is our legend or the category we're going to break it down, is transported. And then bin width is 20. So as you can see here now, we have all the numbers from 0 to 1750 plus. And then if they got transported, yes or no. So as you can see, if they are number, so this is, by the way, the cabin number, so we make it clear, it was between zeros and 250, you can see there's a good chance that they're going to get transported. If it's between 250 and 500, then you can see it's mostly false. Then we have some truths here, then false again, and some truths over here. We could have actually turned this into an integer and visualize it the same way we've done it above here. However, I think this visualization we created down here, the histoplot, is really helping us identify where we can probably find good insights. So how we need to break the data later on, so it's going to make sense for our model. So the next thing I have here, I'm just checking the table. So what am I doing here? I'm just aggregating the data by num and transporter, and I'm counting the people, so the passenger ID, that have 0 true and false, 1 true and false, 2 true or false. So this has the numbers basically that we see above here. So the 0, we have 12 people for false and 6 for true. Actually, this is not just 0, because this goes 0s to 250, so this is probably 0 to 10, I would assume, maybe more, because we break it down into different categories. So down here we can see again where we have most of the transported. I think I've done this to investigate the big numbers. So here we get the big numbers up until 250. I think we're gonna get big numbers. Then from 250 and onwards, we're probably gonna see a lot less numbers. So if we go 250, so here you can see we have smaller numbers. Again, much smaller numbers. Then here we're gonna have a bit more, etc, etc. So this is me just checking basically if what I have done above here makes sense. Right, so based on our findings now, we're going to do some feature engineering. So we are going to create this new column called cabin category, which is basically going to break this visual down into different categories, like 1, 2, 3, 4, 5, 6, and then 7. Right, in order to do this, first I need to make this number into, actually let me visualize it. So let's do .head. Yeah, so I'm going to take this number now and I'm going to turn it into an integer. But in order to turn it into an integer, first I need to deal with the NAs. So what I do is that I quickly set the NAs into this 99999 so I can later on change it back. Then I make the column into an integer. Then I create this new category called cabin category, sorry, this new column. And then I say if the number is less or equal than 300, then it's category A. So basically anything from somewhere here and then on the left is going to be category A. Anything bigger than 300 is going to be category B, bigger than 6 category C, bigger than 900 category D. So I didn't need to do the between because as it goes through, it's going to be updating the categories. Then down here is that I have set the 9999 back to none, and then I have counted the values in each category. So if I run this quickly, you can see that for cabin category A, we have 3,569 passengers. Then for category B, this much, then this much, then the least is category G. So it's basically this category over here. Right. If we continue further on now, we need to deal with the missing values because as we have identified above, we have a lot of missing values. So what I say down here is that since we have a lot of missing values and they are not on the same row, it's basically on the column level, so different values here and there missing, one of the most common techniques is to replace the continuous values with the median and then the categorical features with the mode. So this is exactly what we've done down here. This is our character, so this is our categorical features, and then this is our numbers, so these are our continuous values. So I say for S in strings, then I calculate the mode. So the mode of home planet is the most common home planet we see. And then I am replacing all the NAs, so .fill NA with the mode. And then I repeat the same process for the numeric, but instead of adding the mode, down here I'm calculating the median, and then I'm doing fill NA on each one of these numeric columns with the median. So if I run this quickly, and then if I check for null values again, you can see we only have null values for the name. We haven't dropped the name. I thought we've dropped the name, but it's okay. We can leave the name. We are not going to use the name in our calculations, so I'm probably going to drop it later on. Right, so now that we've dealt with the missing values, the next thing we want to do is to investigate the distributions and then the outliers. So to investigate the distributions, we are creating this dist plot. So first we need to set the figure size, and then we need to look through all of our numeric columns. Then I save the values into this X vector over here, and then I'm plotting sns.distplot. I set the X, which is basically the values of the first column, first numeric column, which is, let me remember which one was the first, the H. Then I say sns.distplot, I pass the values, the color is blue. Then I also plot the mean. So this line here is the average age. In order to plot the mean, first I have to calculate the mean. I say mean equals raw data of age column dot mean. So this stores the mean into here. And then I plot this AXV line. I put the mean into the line. So the mean is my X. Then 0 and 1 is basically 0 and 1, the Y over here. Color is red. I plot the title, which is my column name. Then I plot the plot, plt.show. So if we run this quickly and investigate it, we can see that age kind of follows a normal distribution. However, it's not the case for room service. We have a lot of zeros. Food count, again, we have a lot of zeros. Shopping mall, we have a lot of zeros. So you can see the distributions, they don't look good. So what this means is that we probably need to scale our data. So a popular method is the logarithmic scaling, which we're going to show later on. But before we do that, let's keep investigating. So as you can see, number doesn't have a good distribution either. So straight away after the investigation of distributions, I always like to plot the box plots, because box plots are identifying the outliers themselves, so I can see which columns I need to scale or not, or which columns have a lot of outliers or not. So in order to plot the box plots, again, we need to set the size. Then we repeat the same process as above for C into numeric. So our numeric columns, we plot the name of the column, we store the value. So this is the vector into this X. Then we pass this X into our box plot. We set the color into this color, which is basically a yellow color. Then we print the median. So we have the median, 27. Then we plot the title, and then we also do plt.show. So if we run this quickly, we can see the age spans from 0 to 77 probably. These ones are outside the 4 quartiles, so they are mapped as outliers. Again, we don't need to remove them just yet. We just need to see that they are there and investigate this further. Then we check for room service. You can see because of the zeros, we have a big problem with outliers. Same with food count, same with shopping mall, same with spa, VR tech, and then number is the only one that it's kind of okay. So if I select everything that food court is more than 20,000, if we go to food court, which is, let me see this one over here, 20,000. So anything that is more, so this one's over here, because they're kind of way outside outliers versus these outliers. So if we investigate them quickly, we can see that these people have spent ridiculous amounts of money into this food court. And if we check all of them category cabin A, and then if we check if they are transported or not, so this one over here, true. So this is basically telling me that people that spend a lot of money on food courts, so you can see anything that is more than this is true. So this is actually a good predictor for our model. So this is why it's important to, yes, investigate the outliers, but if the outliers are like this clear, so all of them 100% are true, then this is going to help us with our predictions later on. So I'm not going to remove these outliers. However, what I'm going to do is that I'm going to scale my numeric values, because as you can see, these columns need scale. So conclusions is that we do not want to delete the outliers. We will deal this by scaling the data. So here I import the min max scaler. So this is going to select the min value, the max value, and then scale all the values in between into 0, which is the min, and 1 in the max. So in order to run this, I need to select the columns. So as you can see, I have selected age, room service, food court, shopping mall, spa, and VR tech. So the columns I have identified that need scaling, and then I say equals scaler.fit transform, and then pass again the same columns back into these columns. So if we run this quickly and then we visualize the data, you can see that these numbers now are going to change into a value between 0, which is going to be the minimum, and 1, which is going to be the maximum. The next step we have now is that we need to turn our categorical variables into numeric representation. And the reason we need to do this is that we cannot really apply calculations on these string values over here. This is text. You can't do calculations or maths with text. So we need to turn them into numeric representation. And this numeric representation is basically going to create new columns and add zeros and ones. So just to show you how this is done, so let's run it first, show how it's done and then explain it. So for, let's say, home planet, if we go over here where we have home planet, you can see that we now have home planet Earth 0, and then the second one is 1, and this is because the first one it was Europa, the second one was Earth. So this is 0, this is 1, that's why we have 1 under Earth. The first one, home planet, is Europa. This is why we have 1 under Europa, so this one over here. Then Mars is 0, so it's not Mars. And then we don't have any other value. So 3 new columns for home planet. For cryosleep, we're going to have 2 new columns, which is the false and the true. And we have 1 under false because it's false, and 0 under true because it's not true. So this is what this getDummies does. pd.getDummies. We pass the raw data, we pass the columns we want to change into zeros and ones, and then we visualize the data, and now we have a new data frame, which is basically all with numbers apart from name, which we're going to drop later on. Right, moving on, now that we have finished with the data cleaning and the scaling and all the transformations, we need to select the most important features. So we need to identify which features are very important for our y variable, which is the transported yes or no. So 2 methods that I always follow. The first one is the correlation coefficient heat map, and the second one is the feature importances from tree-based models. So we're going to start with the heat map. By the way, I have information to read here if you want to read how it works. The first thing we have to do is to select the variables we are going to run correlation for. So here I have the n variables, so the number of variables, and I have pasted, I think, the first, I don't know how many, 20 columns. The reason I've done this is because we have way too many columns, so I had to break it down into 2 sets. The first one is this one, and then it's a copy paste, and then the second bunch is these ones over here. If I plot all of them, they're just too much. I can't see them. That's why I've broken it down. So I select the variables, then I run this Pearson correlation, and from my raw data frame, I select these variables, and then I say .core, the method is Pearson correlation. You can see how it works over here. And then I pass these n variables into the columns because I need to set the columns, I think, over here. And then I say AX equals SNet.heatmap. I pass my correlation coefficients data frame, which is this data frame. So let me actually copy it and paste it so you can see what this data frame is. It's going to have all the columns we've selected and then a value between 0 and 1. And age with age is always going to be 100% correlation. Same with room, so you can see ones. So it's going to go all the way like this, ones. And then it's comparing all the variables with all the variables. So they are relationship, and then it adds a value between 0 and 1. However, this one is not easy to read. So this is why we run the heat map, which is down here, which is very easy for us to identify the highly correlated variables. So if we try and investigate this quickly, let's check the one. So you can see site P, it has 100% correlation with site S. It makes sense. If it's not the one, it's the other. So this is the same case with this other true or false. This one has a good correlation. So number with having category A has a good correlation, -75. What else? Do we have any other high correlations? So not much high correlations from what I can see over here. Then if we check the rest of the variables, by the way, this is the rest. Let's see. So this is a good correlation, home planet Earth with, what's that, Europa? Yeah, it's not telling me much. This one's a good correlation with this one, again, it's not telling me much. Good. So because we have a lot of categorical variables, zeros and ones, we can't really get much from these correlation coefficients heat map. However, maybe the feature importances further down are going to give us more insights. So feature importances, we have explained this a lot of times in our previous videos, is a method that helps you identify the most important features that affect the Y. And the difference between these two methods is that this one is a one-to-one method, so it's only comparing two variables at a time, but feature importance is going to take all of the X variables together and try and use them in combination to identify which combination of these variables is going to give you the purest tree, so the highest feature importance. So first, we need to split the data into X and Y. Then we need to run a tree-based estimator. Then we need to run feature importance from this tree-based estimator. And we're going to measure the importance of a feature by calculating the increase in the model's prediction error after permuting the feature. So you can read more about how this method works over here. In order to run it, first I'm importing a decision tree classifier. This one I'm just deleting the data frame so I can rerun it as many times as I want. Then I'm separating my data into X and Y. So X is going to be anything, so all the data frame apart from my Y variable, the passenger ID and the name of the person. So we don't really need this as inputs. And then I say dot values because I'm going to save it in a Numpy array. Then for this one is exactly the same but without the dot values, and the reason I created these X columns is so I can take the columns later on. I'm going to show you. And then our Y is going to be just the transported, so it's a vector of zeros and ones. Then I initialize my decision tree classifier model, and then I feed my X and my Y. So if you want to learn more about this, I have links over here. And down here is where I calculate the feature importance. So I say for I, comma, column in, enumerate the neurodata.drop, so basically my X. So I could have put this one over here. I want to print first the column, so this is going to be the column, and then the second bit is going to be dt.feature importance for the first column. So my I is going to be the first column, and this is going to loop through all the columns. Then I create this data frame where I store the column as variable, and then the feature importance score of the first column under this score over here. And then I go into this try and except. The first time I'm going to try this, it's going to fail, so it's going to save this data frame into final underscore feature importances. And then the second time that we're going to have data again is going to concatenate those two together. So each time we have a new feature and then its importance, it's going to keep adding. So it's going to create a data frame. And then if I show you this data frame, is actually this data frame over here. And what I do here is that I'm just ordering the data frame based on this feature importance. So now we can see that the most important feature for our model is this cry-slip underscore true over here. Then is the VRTech, then is the spot, then is the home planet, and then it goes on and on and on until we find the features that don't really contribute anything. So these features are not really needed in the model because they add no value into our predictions. Right, so now that we have finished by identifying the most important features by using this correlation coefficient and feature importances, the next thing we can do is to actually run our model and start making predictions. So here I call a gradient boost classifier. I set the number of estimators equals to 100, learning rate is 1, max depth is 1, random state is 0. Then I feed my X and Y. So this X and Y is the X and the Y over here. By the way, I haven't shown you what they are. So X is basically a Numpy array. So this is my X. What did I do again? I've changed. So X, it's running. Why does it take so long? Yeah, you can see it's this Numpy array. So it's basically all the numeric values of our columns. Our Y is going to be true or false, so 0 and 1. and then we feed this into our gradient boost classifier. We make a prediction on our X, and then we score our model. So this Y predict, so let me run it. And then let me print this, the Y actual. So this is the Y actual. And then below I'm going to have the Y predict. So Y predict is our predictions on those actuals. So the first one is false, but we have predicted it true. The second one is true, but we have predicted it false. The third one is false. So it's false, correct. We got this correct. We got this correct. We got this wrong. We got this wrong, 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 wrong. So as you can see, we got a lot of them wrong here, but we got a lot of them correct. And a quick way to see a summary is this accuracy we have over here. So the score is basically the classification accuracy. We got an accuracy of 80%. So if we feed the model the data again without knowing the Y's, then it's going to predict 80% of them correctly. Predict probability is the probability. Let me show you what this is again so you can see. This is scientific numbers. I think I have the removing the scientific numbers. Where is it? I think is this one. Sometimes it just doesn't work when I run it here. So if we go back, where were we? Not model optimization, not this one. Yeah, I think this one. So if I paste it up and run it again, you can see that we have a 56% chance to be a yes, and then a 43% chance to be a no. This is why we have a yes into our array over here, the true. So if we check the classes, so you can fully understand this. So if we select the classifier and then we put dot classes underscore, you can see that it starts with false and then it's true. So what this is telling me, the predicted probability is that it has a 43% chance to be false and a 56% chance to be true. So the second one, it has a 97% chance to be false and then 2% to be true. So this is why we start with this is true, this is false, 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 false. So if we check the predictions, you can see we have true and then false, 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 false. So this is how the probabilities and then the predictions work. So if I remove this quickly, we don't need this, we don't need this, we don't need this, we don't need this. And then the other metric I have over here is the logarithmic loss. So we're trying to minimize this logarithmic loss. So just to help you explain again what this is, if I get the probabilities again. So let's say this first model that we have just run, this CLF model, predicted that the first row has a 43% chance to be a no and a 56% chance to be a yes, and it's actually a no. So later on when we run other models, if we get another model that gets this by, I don't know, 80% yes, but this one gets it with 56% yes, then the loss calculates that difference. So this is why we're trying to select the model with the minimum loss. So personally, I prefer using these, it's not logistic actually, it's logarithmic, so it's log loss, sorry, I shouldn't say logistic. So this is why personally I prefer using this log loss versus the accuracy, because it's going to give me the model that gives the highest of these numbers. You can actually read how this works if you Google how logarithmic loss works. So why is this an error? This is because I need to define the log loss. So I don't know why it doesn't save it. So every time I need to have this import. If we come down here again and we paste that at the top and then we rerun this, it's going to work. Right, so the last step now is to load the test data, which is basically this data set over here without the Y, and apply exactly the same data pre-processing steps we followed on the trained data set, so we can transform this data to be exactly the same as the data set we have used to train this algorithm, so we can feed in the test data now and get predictions. So now what I do is that I'm copying and pasting chunks of code from above down here. So the first bit is loading the test data. This is to remove the warnings. Then I am changing the type so we can, I say so we can visualize, but it's so we can apply calculations later on. So this is a direct copy paste from before. Then we are adding the 3 new columns, dropping the cabin. We are creating the same variable as before, which is the cabin category. We are changing the values to mode and median. So one change I have over here is this bit of code which I have just added. I don't know why it was throwing me an error, because it was making the nums to appear as strings, so actual words and not as NAs, missing data. So make sure you add this bit of code when you copy and paste it. Then we scale the data, we make the categorical values into numeric representation, we drop the passenger ID and name, and now this X test is ready to be fed into our algorithm. So if I copy, so very quickly, I'm going to copy this without the values, so you can visualize the data set, how we've done it, .head. There we go. So we have taken this this test data over here that has how many? 13 columns, and we have turned it into this data set with zeros and ones, with scaled data, with new columns. So exactly the same process as before. And now we're going to feed this test data into our algorithm. So clf.predict, which is this algorithm we have just trained above here, the model. And then we have our predictions into yPredict. So if we run this yPredict, you can see that these are predictions that are going to be over here. So this first person, we are saying, what do we have? We have true, false, true, true. So this is going to be true, false, true, true, etc., etc. And then the last step I do over here is that I am creating the output. So what do I do is that I load the evaluation dataset, which is the test, and then I pass into this new column the yPredict. And then I save this evaluation data, these 2 new columns, into my output, and then this output is going to .csv as submission 1. So I'm exporting this into CSV. So very quickly, just to show you what I'm exporting. So this is our output. So it's similar to the sample submission that we got from the competition. So this sample submission, if we open it, it has passenger ID and then transported, true or false. So if we check it again, we have, where is it? Over here, we have passenger ID and then transported, true or false. And then if we also open the file we have just exported, so submission 1, which is this one over here, you can see it's the same format as our submission. So what we're going to do now is that we're going to head over into the competition and submit this file. So we can go into submit predictions. We can upload the file, which is, where is it? Is this submission 1? So open, it's loading, and then we can submit the predictions. What happened? I don't know what happened. Let me do it again. So select submission 1, open, loading, make submission. Working on it, you can see this file got a score of 0.78. So I'm actually going to copy this so we can document it. And then it gave us a position of, this one is just an improvement. So I don't know where 0.78 is going to give you. I think I have it over here. So it's 1000 plus the position that this model without tuning is giving you. In the next videos, we're going to try and optimize, so improve this model more so we can make better predictions. So if we go back at the top now, so we can see in the table of contents, we have covered all of these steps. So we have loaded the data, we've done cleaning, visualizing, missing values, investigating distribution, trained the model, evaluated the model, submitted the model, we got our results. So in the next video now, we're going to try and improve that model as much as possible. And then in the third video, we are going to create the dashboard we have just shown at the beginning. Right. So this is it for this video. I hope you've enjoyed this tutorial and you've gained enough value out of this video. If you feel like you did, then please click the like button, subscribe to my channel, and enable notifications for my future videos. If you have any questions or notes, then please let me know in the comments below. Otherwise, thank you very much for watching, and I'm going to see you in the next video.